This is Obi Science Lab, where we discuss science and mathematics. And today we'll have a chemistry question. So let's go there. It says the volume of a sample of methane collected over water at 12 degrees Celsius and 700 millimeter mercury was 30 cm3. Calculate the volume of the dry gas at STP. So carefully looking at this question, it mentioned STP and volume and temperature were involved in the question. So we should be thinking about general gas equation because of the nature of STP and the involvement of volume and temperature as well, including pressure. So general gas equation says that V1 over T1 is equal to V2 over T2. This is the general gas equation. And let's see the data we have and what we are asked to find from these 6 identities. The first one is V1. From the question, the V1 is 30 cm3, and the P1 from the question is 700. We have 700 millimeter mercury mentioned. 700 millimeter mercury. But there's a twist there. The gas was collected over water. It was collected over water, and there is partial pressure contributed from the water the gas was collected over. And we are given an extra information in the bracket that the vapor pressure of water at this temperature is 10 millimeter mercury. That means there is an additional 10 millimeter mercury in this 700 that we have, which is the partial pressure from the water the gas was collected over. So we're going to deduct this 10, this partial pressure of water, to get the actual pressure of the gas. So it's going to be 700 minus 10, which will give us 690 millimeter mercury. This is the pressure, initial pressure of this containers. So our T1 is 12 degrees Celsius. 12 degrees Celsius, which we must convert to Kelvin, and that will give us 12 plus 273. 12 plus 273 will give us 285 K. So this is the temperature we are using. So for V2, the V2, we have to calculate the volume. We don't know what V2 is, so it's unknown. For the B2, the B2 is the standard pressure, which is the standard pressure in chemistry is 760 millimeter mercury or 1 atm. But in this case, the unit is millimeter mercury, so we are using 760 millimeter mercury. And T2, of course, is the standard temperature, which is 273 K. So we have all the data taken down except for the V2. So we're making V2 the subject of this formula. And when we do that, V2, when it's made subject of the formula here, is going to be V1 P1 times T2. V1 P1 T2 divided by what? Divided by V divided by T1 P2. So V2 is equal to this. Let's put in the figures that we have. V2 becomes V1 is 30. P1 is 690 times T2. T2 is 273. 273 divided by T1. T1 from our identity is 285K. 285, and B2 is 760 times 760. So V2 will be equal to, we're going to multiply these three numbers we have at the numerator and also multiply the denominator to get the value of our V2. Moving forward, 30 times 690 times 273. 30 times 690 times 273 will give us 5651100 divided by 285 times 760. 285 times 760 will give us 216,600. So our B2 will be, and that will give us 26 cm3. That is our answer. So the volume is 26 cm3. And from the options I will have A is 30, B is 20, C is 36, and D is 26 cm3. D is the correct answer. Thank you.